Welcome to the data metaphor space. Our theme today is how replace me to use the quicksort algorithm to divide money. First of all, let me introduce the two guests today, Anita, the scientific superwoman who is determined to surpass men, and Alice, who likes to walk catwalks. Let the two guests say hello to the audience. First, let us look at such a story first. Then come back. After that, the robbery gangs divided their money. So they decided to divide the money according to their age.
Safe code.
The older they got, the more they got. On the contrary, the younger they got, the less they got. In this way, first of all, we need to quickly sort their ages, lest they start arguing again. Do not feel resolved. If the situation is serious, the gang is about to have infighting. The question is, how to use the quicksort algorithm to divide money.
Quicksort is a commonly used sorting algorithm, which is much faster than selection sort. For example, the function qsort in the C language standard library implements quicksort. Quicksort uses the idea of divide and conquer. The baseline condition is that the array is empty or contains only one element. In this case, just return the array as is no sorting at all. Let's take a look at a longer array. It is also easy to sort an array containing two elements.
What about an array with 3 elements?
Don't forget, you have to use the idea of divide and conquer, so you need to decompose the array until the baseline conditions are met. The working principle of quicksort is introduced below. First, select an element from the array. This element is called a pivot. How to choose a suitable reference value will be described later. We temporarily use the first element of the array as the base value. Next, find elements smaller than the reference value and elements larger than the reference value. This is called partitioning. Now you have a subarray consisting of all the numbers smaller than the base value, the base value, a subarray consisting of all the arrays greater than the base value. Here is just a partition. The two subarrays obtained are out of order. But if the two arrays are ordered, sorting the entire array will be very easy. This is called partitioning. Now you have a subarray composed of all the numbers less than the base value, a subarray composed of all the arrays greater than the base value. Here is just a partition. The two subarrays obtained are out of order. But if the two arrays are ordered, sorting the entire array will be very easy. If the subarrays are ordered, they can be combined as follows to get an ordered array. The array on the left plus the base value plus the array on the right. Here, it is 10, 15, plus 33, plus, and the result is an ordered array, 10, 15, 33. How to sort the subarray? For an array containing two elements, the subarray on the left, and an empty array, the subarray on the right, quicksort knows how to sort them. so as long as the two subarrays are quickly sorted, and the results are combined, you can get one ordered array.
Well, just now we analyzed an array of 3 elements. Next, let's watch an animation of a quicksort algorithm. Then come back. Our topic today is how to use the quicksort algorithm to divide money.
This works regardless of which element is used as the reference value. Suppose you use 15 as the base value. This subarray has only one element, and you know how to sort these arrays. Now you know how to sort an array containing 3 elements. The steps are as follows. 1. Select the reference value. 2. Divide the array into 2 subarrays. Elements smaller than the reference value and elements larger than the reference value. 3. Quickly sort the 2 subarrays. Just now, we analyzed a 3-element array. What if an array contains 4 elements? Now, we put the age of the robbery group into this array. The ages of these 4 people are 21, 27, 29, and 33. Let's use quicksort to sort the age array. Suppose you also use 33 as the base value. The subarray on the left contains 3 elements, and you know how to sort an array of 3 elements. Call quicksort on it recursively. So you can sort an array containing 4 elements. If you can sort an array with 4 elements, you can sort an array with 5 elements. Why? Furthermore, suppose there is an array of 5 elements like the following.
Depending on the selected base value, various possible ways of partitioning this array are as follows. Note that the number of elements contained in these subarrays are all in the range of 0 to 4, and you already know how to use quicksort to sort an array containing 0 to 4 elements. Therefore, no matter how you choose the base value, you can recursively quickly sort the 2 subarrays obtained by the division. For example, suppose you use 3 as the base value, you can quickly sort the resulting subarrays. After sorting the subarrays, merge them to get an ordered array. This works even if you use 5 as the base value. It is possible to use any element as the base value, so you can sort an array of 5 elements. In the same way, you can sort an array with 6 elements, and so on.
Thank you two guests for the discussion and sharing today. Let's see you next time.